All right, so let us start with some Cartesian coordinates. So if you are interested, Cartesian coordinates are lesson 65 in week 27. All right. So whenever dealing with functions or graphs, we always deal with a Cartesian plane. And a Cartesian plane is essentially two number lines. So when I draw a number line like this, everyone knows about this number line. We have a 0, we have a 1, we have a 2, we have a 3, we have a 4. And then after dealing with positive numbers, you then dealt with negative numbers, -1, -2, -3, -4, etc. And this sort of number line stuff you could deal with. You could count along this way, increasing, count along this way, decreasing, not a problem. Then, we then introduce a vertical number line. Now, this creates a slight more complication, but everything still acts the same way because it's still a number line, 1, 2, 3, 4, etc. This is still my 0 over there. And then I'm going to get rid of that 0. And then going down, we have -1, -2, -3, -4, etc. So that means that if you are at a given x value, if you're given at a given horizontal value here, so you are at 2 on the horizontal or flat number line, you could have a whole range of values according to the vertical number line. So the Cartesian plane is this thing where it's two number lines together and it is a set of x, y coordinates. So what does the x and y mean? Well, x is my horizontal axis. So instead of having to write horizontal axis every time, which is incredibly long, you can just name it the x-axis. And then your vertical axis is known as your y-axis. And it's done as an x and a y specifically because you always need to give them in alphabetical order. So you'll always give your horizontal axis first, and then you'll give your vertical axis. So if I want to specify this point over here, I'm just changing color. Let's do a light blue. I have that point over there. So measuring from this centerpiece and this center that is my 0, 0 point, that is also known as the origin. So the origin is always this intersection, 0, 0. So 0 on my horizontal, on my x, 0 on my y or my vertical. I want to say, what are the coordinates of this point over here? Well, remember I said always do the horizontal first, then the vertical. Always the x, then the y. So the x value here is 3, and the y value here, even though it's not on the axis, it has the height of 1. So if you say that this point over there is at the point 3, 1, everyone will automatically know that 3 is the horizontal, 1 is the vertical. You can go 3 across, 1 up, or 1 up and 3 across, and you'll get to that point. All right. What about if I have a point down here? Well, this point, even though it's got negative numbers, deals exactly the same way with them as with positive numbers. We always put the x first and then the y. So here is my x. Where is this point along my x? It is in line with -3. And then, where is it along my y value? It is here at -4. So the coordinates of that point are -3, -4. You can say -3 and -4 if you want, but generally they communicate it as number, slight pause, number. So -3, -4, or 3, 1, or 2, 0. It's not 31. And in some books, you might see this written with just a comma. That does not mean 3.1 or 3,1. It is another way of writing this coordinate as 3, 1. So if they write coordinates like that, 3.1 is my decimal version of 3 1/10. All right. What happens if we have a collection of coordinates? So let me draw my Cartesian plane a little bit better. So there's my one. There's my other one. And if I now have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Oops, wrong side for negatives. All right, so that's my Cartesian plane, where that's my x, that's my y. Now, if I have a set of coordinates that does this, all right, each of these have coordinates. So we can write the coordinates of these guys. So it is -5, -5. So -5 on the x, -5 on the y. We have -4, -4, -3, -3, -2, -2, -1, -1. Our origin 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Now, this is kind of going up in the same direction throughout the whole thing. So if we were to group all of these, it kind of looks like a nice straight line. So I can draw a nice straight line through all of these points. And then because this is now a straight line, you can see that it almost looks like it follows a pattern. That every time I go one across, I go one up. I go one across, I go one up. So from here, I go one across, I go one up. One across, one up. One across, one up. And every single time, I follow the exact same pattern. No matter where I am, no matter what x value I'm dealing with or what y value I'm dealing with, it follows the exact same pattern. And because there's a pattern, we should be able to write some sort of formula for it. Now, we can write an equation for the straight line that will relate the x values to the y values. Now, looking at this, we can see this is quite an interesting scenario. So, as is stated on the chat correctly, each x and y coordinate is the same. So that means that no matter what going through this, I know that my y will always equal my x value. That is the equation of my straight line, that my x and my y will always be equal. So the whole purpose of this is if I now take a completely different x value, let's say I have the x value 10. I don't need to now draw this graph, extend my axis there, extend my axis up there, and then extend my graph. It's not going to be useful to me. It's going to waste my life. I'll eventually find the answer, but I could simply use my equation here. If I want the x value of 10, I can replace x with 10, and I find that my y value then will also be 10, and there and then I've got my coordinate that I'm looking for. That is a huge purpose of this equation because it shows the link between each of these points for the x and the y. And it shows that it's a pattern. This pattern will stay the same irrespective of where you are on this Cartesian plane. All right, let's try do a different kind of graph. You can wait. All right, and I need to draw back one more line here. All right, so let's eliminate that. So let's try something else. What if I had a situation where my equation was, let's say, 2x plus 1? You know, let's not be too complicated here. Let's just be x plus 1. So y equals x plus 1. What does that actually look like? Well, it means that whatever x value you look at, the y value is going to be 1 more than that x value. So if I look at an x value of minus 5, my y value is not going to be minus 5, it's going to be minus 4. At an x value of minus 4, the y value is not minus 4, it is minus 3. At minus 3 plus 1, the y value is going to be minus 2. At minus 2 plus 1, y value is going to be minus 1. I didn't draw that correctly. Minus 1. At minus 1, my y value minus 1 plus 1 is going to be 0. At 0 plus 1, the y value is going to be 1. At 1 plus 1 is going to be 2. At 2 plus 1 is going to be 3. At 3 plus 1 is going to be 4. At 4 plus 1 is going to be 5. We draw our straight line through it. And we notice that this straight line is different. And you would hope that it's different because the equation is different. The way that the x coordinates relate to the y coordinates are different. That's minus 5 minus 4. minus 4, minus 3, minus 3, minus 2, minus 2, minus 1, minus 1, 0. And that is 0, 1, 1, 2, 2, 3, 3, 4, and 4, 5. So we can see these coordinates are different. The x value plus 1 will give me my y value in each case. That is the purpose of your equation. It is to relate a whole series of coordinates together as one closed form. This equation is your key to being able to tell anything about these points, shown or not shown. So if I sub in an x value of minus 100, minus 100 plus 1 gives me minus 99, meaning that my coordinate will be minus 100 minus 99, and that does indeed follow these coordinate forms. So we have three different kind of lines, should we say three different kind of line graphs that we could come across. We have the horizontal line, we have the vertical line, and we have the diagonal or oblique line. All right. A horizontal line is one where on your Cartesian plane, you have a line that is just flat. So this coordinate here could be, for example, 0, 3, 1, 3, 2, 3, minus 1, 3, minus 2, 3, etc. So irrespective of what the x value is, the y value will be 3. So if I need to give you an x value and I say the x value is 50, what's the y value going to be? Well, it's 3. If I give you the x value of 100 or minus 1,000, what's the y value going to be? It's going to be 3. So irrespective of the x value, you know that y is going to equal 3. And this is one of the forms of your straight line, in that if it's a horizontal line, the y will always equal a number. Whatever number this cuts my y-axis on, that is what this number is going to be. Similarly, if we have a vertical line, and it could be over there, and let's say this is 2, 0, that is 2, 1, that is 2, 2, that is 2, minus 1, that is 2, minus 2. If you have something like this, you know that the y values are changing, but they can be anything, and I know that my x value will be 2. So hence here, my equation is x will be 2. Irrespective of what y ends up being, x will always equal 2. And once again, it will always equal whatever number is in the x coordinate, whatever number you cross my horizontal axis with. And then your diagonal or oblique lines, those are the ones that we've already had a look at, the y equals x or the y equals x plus 1. It is ones where they happen at an angle. All right. Draw. Happen at an angle. And if this happens, you're going to have some equation with both x and y in it. And it will be in the form y equals my gradient times x plus my y intercept. In short form, that is known as y equals mx plus c. And what I'm going to do is I'm going to deal with this and a bit more graphing in our next live lesson.